I did the left column for 2 of them.
Y'all have gyms and names.
Then I remembered that I had physics after I got on.
Duh, I know how to. I think I should put. You don't
Yeah,
have to put on
I
there.
remember that I had physics and then I stayed up till like.
Probably happy. Yeah.
She's probably good.
Oh, also I forgot to staple this. Turn loud.
Wait, why does it matter if you did that?
Because you were supposed to. No, you were supposed to make a map
Okay, well I
of.
can't we do that if that's.
Have you ever had one of those?
He just gets in this crappy mood and then does not listen to
You
anything.
could so stubborn. God.
I feel bad for him, he has to dissect a frog all by himself. And I feel bad for him. Why are you gonna do it? I'm not his partner.
Maybe he's so stubborn that he won't do it.
Was he not here?
No, he was here, there's just an odd number. And
Oh.
McCall was like, you either partner up or you're by yourself, so whoever works it out. Alrighty, so he ended up being.
We have to finish our speech.
Dissecting.
Which part did you, which category?
The eyeball
did
is
you
the
choose?
red.
No.
Two more, yeah,
last
me and Lauren
category,
took that
because I
out.
like practicing.
What was it?
No, like the actual.
Like the one finding out who takes longer to get ready in the morning.
You do a cow's eyeball.
Which one did you do?
I haven't done it yet.
Oh, you haven't? Did she like run out of time?
Yeah.
What are you talking about?
We have our Spanish, like, we have to like speak. Like, we
Oh,
have
yeah,
to
I have
like,
3
speak
tests
for a
today.
test.
Whoa.
Better have 3 tests today than 3 tests tomorrow.
I will be here tomorrow.
I know, that's why I said better have it today than tomorrow.
Well, actually, I would
That's a
have
lot of writing.
2 tests today and 1 test.
Yeah. That's why I had to do my
I'm pretty
worksheets
sure-
at like.
Well, I have
Midnight.
nutritional wellness
Pretty
and
sure
Spanish.
Oh, don't worry about it. And I'm gonna be really upset if I don't, because then my grade's gonna.
Okay, so we're talking about, this whole section was about
Physics.
continuity and what makes it continuous or not continuous. Okay? So this is a theorem that talks about whether, if a polynomial is continuous everywhere, from negative infinity to infinity, okay? This is gonna make it like where you can find the limit, okay? Then any rational number is continuous wherever it's defined, that is it is continuous on its domain. So finding the limit of x goes to negative 2 of this function. Okay, this function, yes, has a domain where x cannot be a number. Okay, what can x not be on this function?
A number.
What number? Like a specific number. What can you not divide by?
2. Oh.
Negative.
You can't divide by 0. So what number doesn't work for this?
5
5/3, right?
I'm not sure.
Good job, Lucas.
I thought I was bad at 7 o'clock in the morning. Okay, so this is defined where x such that x is not 5/3. Okay. Does she do such that as this or such that as this?
Was what?
She hasn't done.
I don't know. We have not done.
You have not seen that?
No.
Okay.
No.
Okay. What? Okay, now, is the limit approaching that number? Okay, hang on. Are we finding where the function approaches that number? Where are we finding? So we can still go ahead and find the limit, okay? Because that means it's going to be continuous everywhere, and where it would make the function 0 does not affect where the limit goes, okay? Because the limit is approaching negative 2. So how would I find the limit on this problem?
Okay.
Just plug it in, right? So I would do negative 2 to the third plus 2 times negative 2 squared. You just plug it in for x. Now, when you have, like, if it's somewhere you divide by 0, that's when you have to try to factor something and get things to cancel. So you're gonna have an issue in there, okay? So this would give me what? Negative 8 plus 8 minus 1 over 5 plus 6. So this would be negative 1 over 11.
So how did you know you could just plug in negative 2?
Because that's what this number says, okay? And that doesn't make this 0. This is the only part that would make that 0. Okay? So that means the function would be continuous on the whole domain.
What if the number that you get for the what equals 0 is the same as the one?
Then you would have to try to factor and get things to cancel, or like, you guys have problems on your homework where you like multiply by a square root? You'd have to go back to what you've done, like, what was it, 2, maybe? Just to factor stuff?
Yeah, 2, 3.
2, 3, okay. For you to like, you had to, hang on now, if it is this, you couldn't do that because that would make that 0, right? But I could factor this into x plus 1, x plus 1, and then those would cancel. Then I could find my limit, which would be 0, because negative 1 plus 1 is 0. Okay? So I'm just showing you like that's why they have this theorem. So even though we know you can't have x as 5/3, you can still find the limit. It's still gonna approach a number. Okay? We good on that? Okay. We may get done early. Yes.
I just noticed, because I was doing it on my own, you subtracted 3x, so should it be plus 3x divided by positive? Oh, you subtracted 5. Okay.
And then 5 instead.
Okay.
So either, if you moved 3, then they would both have been positive.
Yeah.
And then you may be asked to find where is a function continuous at. Now, this is where you're gonna have to like think back to some rules that you learned in chapter 1. Or maybe like algebra or pre-calc and trigonometry. Okay? So if I want to find where a function is continuous, that means I need to find where every single part is continuous. Okay? Okay, do you remember the rules about logarithms? Can't take the log of,
You just gonna have to tell us.
okay, you cannot take the log of 0 or any negative number. Okay? So if I want to find where is this continuous at, it would be continuous from 0 to infinity. Now, I can still use the 0 because the 0 doesn't have a bracket around it. You okay?
I was on a chill flight,
Oh, I thought you were like gonna clap for me or
That's
something.
what I thought he
Yeah,
was
it was.
doing randomly.
I was like, he's just randomly like gonna clap. Like. So, because I don't have a bracket, this means that it doesn't include 0. Okay? Do you remember tangents? This is actually tangent inverse. Okay, it's continuous for all. So this would be continuous from negative infinity to infinity.
Isn't that what the vertical asymptote?
It does have the tangent does have vertical asymptote. This would be the inverse, which means you can find an angle for any tangent value. Whether it is 0, 180, 360, you still can find the angle.
So why does that not have brackets?
Why do none of these have brackets?
Why does the
Okay,
tangent inverse not have?
Infinities never have brackets because you can never include an infinity.
Okay.
Because like think of the biggest number you can think of. There's always one bigger or always one like smaller.
Okay.
Okay? Now what about x squared minus 1?
Can't be one.
One.
Can't be 1 or can't be what?
Negative
Negative
one.
one.
Okay, so it can't be 1 or negative 1, but it can be everything else, right? So it could go from negative infinity to negative 1. It can go from negative 1 to 1 and 1 to infinity.
Oh, shit.
Is this where you're
So is that one of
brackets?
these?
Why
Cause it's
does-
not included.
It can't be those two numbers. So I can't include any of those.
And
Okay.
it's only because that's in the denominator, right? Like if that was in the numerator, it wouldn't matter.
Correct. Well, hang on, no, because this is continuous, you're still gonna have those holes. Yes, 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 yes. 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 Because it's in the denominator.
Yes,
Yes.
yes, yes,
Well, I don't wanna confuse anybody, yes. But this doesn't matter and this doesn't matter, because no matter what, you can't take the log of a 0 or negative, okay? But yes, if this was in the numerator, you would have no problems, nothing, it would be negative infinity to infinity. Okay, so then you wanna find, what do they all have? I have to find where they're all continuous together. Okay, so like, this one's the whole spectrum, right? So, that's not gonna simplify things, but this one can only be from 0 to infinity. So, if that can only be from 0 to infinity, that's where I know at least I have that starting point. This doesn't matter, because this includes everything. So I'm like minimizing this down to whatever it could be. Okay, well that works for this one, that works for this one, but does 0 and infinity work for this one? No, right? So what would actually be my, where it's continuous? 1 to infinity.
Wouldn't it be 0 to 1 and 1 to infinity? Like, could you include the 0 to 1?
Yes, we can. We can't include this whole thing. Okay, now, neither one,
Wait, yeah, I was like, can we move it back down?
no, you can't. Why can't we? I was going to, but why can't we?
Because you can't take the log of
I
zero.
can't take log of 0. If I had a bracket here, I could. Okay.
Why did you just add the 0 and 1?
Okay, so, are you okay with how we got from here to here, but then we got to here, it doesn't work?
Yeah.
Okay, so we know this works, but we also know 0 can still work. Well, since from negative 1 to 1 works, that means from 0 to 1 would work, because that matches this stipulation. So we'll include that up there in our answer.
But isn't that like not continuous though?
The function is continuous as long as it's inside these intervals. The function itself is not continuous, but if I use this as my domain, then it makes the function continuous. Because I'm like bypassing where it's not. Okay? I'm like restricting what I want. Are you having fun yet?
Tell me.
This is your guys' last morning with
We don't come in tomorrow?
No, normal time tomorrow.
Why not?
Tomorrow was the one day I was gonna go home and take a nap and I needed that. I
Well,
was so
Wow,
excited
that
about that.
sucks.
you can sleep in tomorrow. How about that?
Why not tomorrow?
Because she's back today. And you guys know. Or you didn't know yesterday because we didn't find out till 2:13.
On the dot.
Well, that's what the email was saying.
Okay, that's so like,
So yeah, actually, I
Pretty
did know,
precise.
I did know at 2:15.
I was checking, I was making sure she actually said that.
It's gonna be easier for me to show you an example on this than it's gonna be to try to explain what the theorem is.
Is that an equals?
Here,
No.
here,
Yes.
yes.
Okay, sorry, I was like, it's kind of close, wasn't sure.
And we're just gonna do an example. instead of trying to explain theory to you. Although I know how much Carly loves theoretical calculus.
As long as it's grammatically correct.
Is that an example or?
No, that's just like part of the theorem.
Okay.
Okay, now you've done like f of g's and g of f's before, right? Okay, like f of g, we put g in for f, fog and goff, okay?
I just explained that to so many of your pre-calc kids at lunch.
Because they had a quiz, and I wasn't here, okay? So what this is saying is, if you know what that value already is for g, and you're doing fog or otherwise goff, that just means it's going to be whatever it is as the function of that number. So if you already know what this is, it's the same essential thing. Okay? Which then translates to this. If you're finding fog or goff, this would be the same if it was flip-flop. Like if this was g of f, then this would be g and that would be f. Okay? You can find, if you want to split this up, you can find the limit of this inside, then it's fine multiplying by this to find the limit of the whole thing. Which is why we're going to do an example so you can see what I'm talking about. Okay? I think you'll be okay. I think you'll understand. I mean, you might not like doing trig, but this involves trig and it involves getting rid of the denominator because it's not continuous right away. So we're going to be reviewing like 3 things in one example.
Are we gonna have to know our unit circle again sometime soon?
Yeah, like today, like right now.
Oh my gosh.
Good call, Maddie.
I never learned it.
It all builds. Like, you don't just like take a class, you're like, bye, I'm done with you.
Why not?
Are you sure? Because I've definitely done it.
Well, you shouldn't. Okay, so what this is saying, if I want to find the limit of the whole thing, I can take this f part and put it on the outside. So I'm going to find my arc sine after I find the limit of x goes to 1 of this.
Wait, I'm already confused.
I don't even know what an arc sine is.
Sine inverse.
Oh.
So you're given the answer, you want to find the angle. Here, we're going backwards.
Oh,
We
so
did this
why
in
did you know
trig.
to do that?
I don't remember.
Why did I know to do
I
this?
vaguely
Switch the
remember
limit.
now.
That's just saying that that's what this property is. Why would I do that? Well, a sine has nothing to do with square roots. Okay? So if I can, if I'm allowed to, which this is true because you have 2 functions going on, this says I can bring one of them out front, find this, then it's just doing the arc sine of that value.
How do you know they're 2 different functions?
Because arc sine is a different, it's just like if I had, like if these 2 were multiplied together, those are 2 different functions. Like if I had something here and then this, that would be 2 separate. You can combine them, they're combined together, but things that are combined together, you can split them up. Like these are still being multiplied together. Just the ruling says I can now multiply it out here instead of finding the limit of that first.
So could you split that into 3 if you really wanted to?
Not this one because you can't split that up. Well, you have to do this over that, like this over that, and then this over that. But this is an adding problem, not a multiplying problem. Like that would be this over,
Yeah.
does that make sense? And that doesn't, this is only true with multiplying.
So the F is with the arc sine.
Yes, yes. Okay, now this is where you have to think like, she said it's from 2, 3. As x approaches 1, that would give me an error, right? Can't do that? So do you remember how to get rid of those? Okay, you gotta rationalize. This one has a square root. So you're gonna multiply by 1 minus the plus, sorry, because it's the opposite. Square root of x. Now I know you're used to rationalizing when you have denominators. Okay, it doesn't matter, wherever the square root is where you have to rationalize. So that arc sine still, or sine inverse, would you feel better if I put that?
Yeah.
Okay, they mean the same thing. Okay, so if I distribute on top, this would give me 1 plus square root of x minus square root of x minus x over those two multiplied together.
So all you did was just distribute the.
Yes.
Okay.
Now, I'm not gonna distribute the bottom because what do you notice on top's gonna happen? These are gonna cancel and then I'm left with on top 1 minus x, or, yeah. So what happens then on the bottom with the top? Which is the whole reason we did this. Because the whole thing was to get that part to cancel. So now those cancel. So you find the sine inverse of the limit as x goes to 1 of 1 over 1 plus the square root of x. And now you can actually find this limit. Okay, what would the limit be? Okay, what's the square root? 1/2, right? The square root of 1's 1, 1 plus 1 is 2. So this is a half. Now we can throw in our sine inverse. So now we're gonna find where is sine a half. So this is where like your unit circle comes into play. So if you did it in radians, it's pi over 6. Did it in degrees, it's 30 degrees.
So you put the 1 in because x is approaching 1?
That's what the inverse means. Inverse just means you're given the answer and you work back to find the angle. So like if I were asked to find sine, I would mean find sine of an angle. The sine inverse means I'm given the, so your sine's the y value, right? So it's the y value, where is my angle at? Because cosine is your x.
So you put in 1 for x because the limit is approaching.
Yes, yep.
And then,
Would we have to go farther if you can't plug in 1 for that?
You should always be able to, and once you rationalize, something should cancel if it doesn't work the first time.
That's why we did all that work. So we did that. So it didn't even do it.
Okay, so this was your first quadrant, right? Sine was y, so that's why I went here. And then this angle, that's how I got the 30 degrees and the pi over 6.
How did you know it wasn't on the second
Because when you're thinking about doing everything, you're restricting yourself to the first quadrant. Unless cosine's negative, then you would go to your second. You're not thinking of the whole circle like we did in trigonometry. You're thinking of what happens up here.
quadrant?
Okay, I know sine's positive in both places, but your initial, like your standard would always be quadrant 1. If it doesn't fit in quadrant 1, then it's automatically going to be in quadrant 2. 3 and 4 are not your
and sine
like
is
standard
always y, right?
thoughts. Does that make, that's like if I asked you what the square root of 9 was, you wouldn't say -3, because the very first common one to you would be 3. Yes, -3 is the square root of 9 as well, but it's not, that would be like the ones that are down below.
Okay.
Does that make sense?
Yeah.
You're not going to be expected to know both. Like in trigonometry, we always had to do everything that was on a full circle. Full circle. Well, I forget, like when I do things to me, it's backwards for you guys.
I think we got the
It's
gist.
still a circle, but it's how you go.
Like cotangent.
Because like when you measure angles, you guys go this way,
It's
but that's backwards for me because I think it is.
What's the third one?
Secant.
Secant
is opposite of sine.
Oh my gosh, what do you think?
If you know sine, cosine, tangent, you'll be okay, because the other ones are reciprocals.
But then when you just.
Secant, cosecant, cotangent.
I don't remember which one.
But they don't go together, right? The ones you think would go together don't.
Correct, so sine goes with cosecant. Cosine goes with secant.
Why did they make that easy?
I don't know, like that's.
I never got used to that.
And then,
I feel like it's
Oh,
like
it's
sine,
fine,
cosecant,
yeah.
and tangent,
Yeah.
and
Is
then
that
it goes to
fine?
I think they just think the most
cosine,
complicated
cosecant,
thing that it 100% should have been.
that's why I got.
I really don't know.
Alright, this is your last, I don't know why I wrote theater right
Hey, I
here.
can refill them.
No, I'm not. Oh, it's on those.
We're gonna look back and be like, bro, we were stressing out for calculus our senior year, and probably Lucas and Carly and Corey and Ruthie are the only people that did these.
Thanks, babe.
Thanks, Faith.
You're welcome.
I'm kidding, I'm never gonna use
it.
I don't even know if I'm gonna use it. Ruthie, what do you wanna be? An adult. I don't know.
Used.
I'm already an
Like
adult.
Lucas says he's
technically.
gonna be engineer.
All I'm saying
I'm pretty
is,
sure Carly or Corey are gonna be the president.
I'm not going to handle my
I'm gonna be what?
The president.
Yeah, and they're totally gonna need
Once I
calculus as the
study-
president.
I know.
She's gonna figure out
Lucas
a way
is
to
gonna be
actually teach it. Oh yeah, Lucas is gonna be president. Madison, Chloe, and Abby are gonna be.
Oh my gosh.
I thought Lucas was gonna have a bunch of wives.
Yeah,
sister wives.
That's
Sister
part of the
wives.
story.
Remember the candle dance?
What?
The candle dance. That was good fun. We need a brain break.
Okay.
No, it's okay.
Let's use
That
your time
easy.
wisely.
Just get it over.
We need to get this over with.
I was late for anatomy yesterday, so yes, I want to.
I like walk through the doors, the bell rang, I was like.
You were late for Nani from here?
Yeah, because I had to go to my locker and like unpack my
And
backpack.
socialize. Because you were late coming here.
And socialize.
Yeah. I always socialize.
We
Yeah.
understand that, Hannah.
People
Clearly.
stop and talk all the time.
Maybe that's why you were late.
Not when they're gonna.
Actually, yesterday morning I had a lot to unpack.
She tells her life story to people at Walmart.
My mom does that.
No, here's what I do. If I see someone I know, I'm like, you're so and so, right? And they're like, yeah, and then we just connect and we just start talking.
Even if she's met them one time, she just walks up to him.
Probably even if she's never.
You're like my grandma.
You know how often I do that at the car wash? Someone will
Photograph.
pull up, I'm not, like Hannah Zanowski's dad came through, I'm like, hey, you're Hannah Zanowski's dad, right? He goes, oh.
Grandma Ford.
Already asked
She
her.
knows everyone. Telling me your life.
My senior year in college, I went on a trip. We went on a cruise because my spring break was ever different because I was doing my student teaching than what IU spring break was. So my mom and my grandma and me and my mom's two sisters all went on this cruise together. And I'm flying, like we're flying down to Florida, and I'm sitting by myself, like we're all kind of by ourselves, and I can hear my grandma talking the whole flight. And I'm behind her, and as I'm getting off the plane, everybody's saying, congratulations, Emily, congratulations, heard all about your life. And I'm like, oh my goodness, Grandma, like what did you say about me?
That's funny. That's definitely
Like my grandma, she has no enemies. No enemies, no strangers. Okay, so suppose that f is continuous on a closed interval. Let n be any number that's between f of a and f of b, where they're not the same. Then there exists a number c that's inside there, such that f of c equals n. Okay, what is the point of knowing this? Point of knowing this is to prove that there's a root on a graph that's between two numbers. And this is in your homework, like 2 or 3 questions. So I'm going to do my best to fully explain the theory behind of why you pick such numbers.
Yay.
So,
Here's your problem. You guys want to know what this number is? That's your problem. You're not okay with just showing that there is a number. You want to know what that number
I want
is.
to know what the people who made this up were on.
Bro, something strong. Like nobody just texted this.
Why are we as smart as what these people used to?
Just
You
think they
think
did all
there's
this
people
with
out
like
that smart right now?
out
Well,
calculators.
Lucas, you see people coming up with new calculus series.
Yes,
Why would they-
every day, all the time.
Because they don't need to.
They're,
They're coming up with. I'm confused.
they're working on like theoretical physics or something.
Yeah.
Quantum
Grammatical.
mechanics. Theoretical. I'm never gonna live that down.
Grammatically correct. Okay, what does it mean if you have a root of a function? Like, what is a root?
Pardon.
It's a 0 where it crosses the x-axis, right? Okay, root, zero, solution, x-intercept, those are all called the same thing. That's only the 35. We'll be done as soon as this problem's over, okay? Alright, so you need to just prove, you don't have to find what the number is. You're just proving that there's a root between 1 and 2. Which means either at 1, the answer is above 0, and 2 is below, or you're proving that 2 is above and 1's below. Because you gotta prove that if these are on roots, they're gonna have to cross the x-axis somewhere, whether it's this way or this way. Does that make sense what I'm saying?
Yes.
Okay, so if I